All right. Hi everyone. So welcome to the session of the Keep Calm and Adopt DevOps. So today I'll be talking about the framework around DevOps, which is called the CALMS model. And let's see what I'll be talking over. And basically, I am a cloud and DevOps enthusiast, and I work in the cloud and DevOps space from close to 6 years now. And I've been living in Singapore for close to 4 years almost. So I did a master's degree from software engineering from NUS, and then I'm kind of a cricket fan and an amateur football fan. So that's pretty much about me. So moving on. So what would be I covering in this session is basically about the introduction to about DevOps and what are the concepts around DevOps, so just basic introduction, and what are the myths around DevOps design patterns, and then the challenges which you're facing in the current day organization, and the DevOps, how can DevOps help you in the rescue, and of course the last part is the important, the model which is built around the DevOps. So on a quick show, like how many of you heard DevOps and know basic idea of DevOps, so that I can start off accordingly. So if there's, because okay, that's quite a few hands. So I will be covering the introduction to DevOps a little fast because there are quite a few people who know about it. So okay, so now moving on. So the DevOps part, the important. So the standard definition of DevOps, whichever website you see, they say it's the practice of operations and the development engineers working together in this entire SDLC lifecycle, or also a software lifecycle, is right from planning stage to the application production stage. You have this entire setup. This is the basic definition. When you Google about DevOps, you get it. But what exactly DevOps says, like there's a common misunderstanding that DevOps is all about automation and nothing more than that. But today we'll be seeing what exactly is there other than the automation and what are the qualities behind the DevOps. So, and then the life cycle of DevOps. So what you see over here is the common diagram when you see about the DevOps, where you plan your code stage right from the initial stage, and then you kind of code your requirements as per you have developed in that particular sprint or phase, and then you build your automation, build your jar files or anything, and you test your code and you release your code, you deploy and you operate, and then you monitor your source code. So this is done on an incremental basis, and it's a never-ending basis. So you have a feedback loop over here which will be saying about the entire life cycle, and it's never ending a process. It's just a continuous, and there's always, you learn from your mistakes in your previous cycle, and then you learn it and you fix it in your upcoming cycles. So this is the common diagrams when you see of a DevOps. When you Google DevOps, you see all these things. And then what exactly is DevOps is, there's a miscommunication, as I told you, that there is a DevOps engineer who is supposed to do the DevOps, and then there's the development teams who are responsible only for the development activities, and then you have the operations guy who takes care of the operation activities. So basically what I want to say over here is DevOps is not a single person job. It's everyone's job in that particular team. There's no exemption that he's a developer, he's an operation, he's somebody else. So that's the main motto of DevOps. And what are some of the common myths which you hear in the industry is, you combine both the developers and you combine both the operation team, call it DevOps. You remove the operations, keep something and rebrand your name and call them DevOps. You use cloud, I am a DevOps motto team, and sacrificing governance, remove all the process in between, just deploy straight off, it's called DevOps. But when we question ourselves whether is this correctly DevOps, most of you must be thinking there must be more than what it is. So I wanted to cover on that part, like what exactly it is other than the automation. So this is some of the anti-patterns and the patterns of the DevOps, which will make you a DevOps to DevOps if you do something anti-patterns, when you follow these patterns. So first part, okay, I'm sorry. So the first pattern, which you see both the dev and the ops, which work in silos, and then you have the dev and the ops, and then this is the latest kind of technology where people say, well, I'm creating a DevOps team. Ideally, you're creating a third silo over there other than the existing two, and then you remove the operations and you just keep a dev and use some kind of rebranding yourself, hire in an operations guy in your development team, say them, we are DevOps without the operations, and then this is the most common thing which you'll be hearing in your workspace. I'm using Terraform, I am DevOps. I'm using Jenkins, I am DevOps. I'm using Maven or something, all build tools, and I am DevOps. So anything, whichever toolset we are using, there's a common misconception that we are using DevOps, and this is something dangerous actually. So rebranding the system admin, meaning they will be hiring some DevOps engineers into the operations team and call themselves a DevOps team. But actually it is much more than that, and there are some flaws in that also. What will happen if you undergo this practice? And then so moving on, the patterns which the community suggests. There's no standard rule that this is DevOps. It's all driven through community. It's the agile community. There's a DevOps community which say what should be the better practices. There's no best practice. There's always a good practice or a better practice. And what they say is, basically, if you see the structural patterns over here, the dev and the ops should collaborate as much as they can. And if they have fully shared responsibility in this particular sprint or in a life cycle, it is much more. The more they collaborate, the more trust involves, the more things go. And somebody else say operations as an infrastructure as a service is also an ideal way to implement DevOps in the new cycle. This is some kind of a misconception that you use DevOps team, that if you call your team as a DevOps team, it is not correct. But actually you can hire someone from DevOps as a consultant, and you can help them move the services and make sure that to the beginning, some companies cannot afford to implement these DevOps practices because of budgets. A lot of reasons will be there. So in such cases, if you can take somebody from external service and then you kind of implement the system with some expiry date saying that, okay, for next 1 year, your goal is to do this thing, particular task, and over that time, you kind of remove that person slowly out of the process, and the team should be self-sustainable. If there is a DevOps guy or if there doesn't exist a DevOps guy, the process should be implemented. So that was a quick introduction. I know it's very fast. So that's what we have seen. What is DevOps? You see the life cycle of the DevOps, and then some myths around the DevOps, and then some patterns and anti-patterns, and then the challenges faced in the organizations. So what exactly the challenges people face in the organization is the silos. So every communication, every crucial information between the teams is always through a collaboration. If they work in the silo mode, things doesn't work. There should be always a communication which should be running through both the channels, whether it is a dev or an ops, because there's always a conflict of interest between both the parties. So organizations always pretty frequently get into this fight of you versus me. It's dev issue, it's ops issue. I don't care. It's not my issue. It's working fine in my local. This commonly you hear these things which you hear in the organization. This is again one more common thing. Work fine in dev. It's ops problem now. I have nothing to do. My jar is working in my local. My DLLs are working in my local. I don't care. So this is something which should go. There's not your issue, this is not my issue, it's actually our issue. Now time when somebody identify the issue is our issue, that's the time when you're moving towards DevOps and you're adapting the culture of Agile and the DevOps mentality. And then the one which I was saying is always the ops versus dev, it's always like a tug of war. Developers will be always thinking to implement the newer capabilities, new features, go live, I want to impress my business, I want to do this. But there's another guy who always stops them, called the ops. His main motto is to make sure that the thing should be stable. I also agree that you want to go into the production, you want to implement more features, but on what cost is the question which you should ask yourself, and then focusing on the applications more with 99% SLAs and so-called thing. They have their own things. So these things are not communicated between the parties. The devs doesn't know this thing and the ops doesn't know what the devs are talking about. There's a huge miscommunication which you hear. I believe most of you guys have faced this in your organizations. How can exactly we achieve this? How can we achieve this deadlock? Is it only through communication? Is it only through collaboration? There are many more ways, like you can implement some strategies and you can follow some principles which we'll be seeing. And this another miscommunication, that you have a development silo and then you have an operations silo, and then they create this another silo called the DevOps silo. So sounds good actually in some times that, okay, I have my DevOps team who's taking care of my automation. I deploy into OpenShift, I deploy into AWS, I deploy into OpenStack. You have a hell lot of places to deploy. but at what cost? So there's always, you're creating another silo and you are creating an extra dependency on this person. What if your DevOps teams, did you ever come across this situation? What if the DevOps team people go on leave? Most of the work will stop. They say that I don't know, this particular job was triggered by the DevOps guy before. I'm not sure, I'm not pretty sure what happens over here. And the vice versa situations you will be hearing a lot. So there's always a conflict of interest. Previously you have to deal with two people called development and operations. Now there's another headache called DevOps if you don't follow the processes. So when they do it in the agile way, so they have their own planning, the devs plan their own purposes, and then the heroes, so-called heroes, the DevOps team, they sit behind the screen and say, okay, we do DevOps, you figure out your own development activities, we will help you deploy. But is that correct is what we wanted to know. And then how can we break down these silos? First thing is, DevOps is not an automation or anything, it's just a principles or it's just a practices. So you always hear agile saying that it breaks the communication barrier between the business and the development. The business will clearly inform the requirements to the development, and the development can figure out what needs to do, and you can have your clear ideas. But then nobody cares about what is happening behind the screen after development. So that is exactly called the DevOps practices. The first half of your frame will show you about the agile practices and the agile framework, and the second half says about the DevOps practices and the DevOps frameworks. So what we have seen so far is basically about the silos in the IT industry, conflict interest between both the parties, and then creating a new silo called the DevOps team, and then breaking down of silos, and then we'll see about the DevOps, how can DevOps come to the rescue mode. So there's this guy called Ginny Kim, he's pretty famous guy in the DevOps industry. He's an author of the DevOps handbook. So he suggests 3 ways of how the things should be moving. So first way is the flow, the system thinking. It's about the continuously delivering. So imagine you have a Kanban board where you have dev team sits and they have their own Kanban sheets, and they move the tasks from to do to done. And then once the done is taken, the ops will pick up from the ops will be picking up the development done task and try to deliver. It's basically shift right. So you are moving everything which are there in your development activities to your operations activities. But then there's another one called the feedback loop. So this always shift left, which is left to right, and then when you have a reciprocation of feedback which is coming from the operations back to the developers, like a feedback loop, and that's called the proactively monitoring, and that is basically a reverse of what is happening in this one, so which is an end-to-end cycle. And then the third part, which is the most important and most curious thing to know, is about the continuous learning. So the third way is basically to implement growing and change. You want to grow and you have to change your processes. You cannot be stereotyped, I want to do in this particular phase, I wanted to do in this particular way. The things doesn't work like that. So you have to move, you have to learn and unlearn during the stages. And then if you follow these phases, the devs will push their code, push the activities to the ops, and then the ops will push back the feedback to them, say what went well, what went good and what went wrong. And then you have a small iterative cycles which is done on a frequent basis. So it's not a shorter life cycle, it's actually a longer life cycle. So you get to know more and more. So the team is not scared of getting failures. So I don't want to go into production, my code might break, is one of the common things which you hear in your organizations. The more things grow, the more you try, the more you fail, you will be not scared of failures. That the team should be well aware and they should embrace the so-called failure part. So I pretty much covered what all I wanted to say over here. It's just the points which is done. Basically shift left to right. You want to development activities will be pushed to the operations, and then you want to do what happens over here is it reduces the number of handoffs, and you wanted to eliminate the hardships between both the parties, and then you have a large number of increased flow from the devs to ops. And then you have the feedback loop. Is basically you want to increase the information flowing between the systems, between the devs and the ops. The more feedback it goes, the more familiar with your system, the more conscious you are about your upcoming releases. And then pushing quality is another thing, because again everything comes back to that, embedding knowledge for where to use and when to use. And then the third part is creating a safe environment. When you try a lot, you know a lot, you figure out a lot, and then creating rituals which between the teams, and now taking risk will not be a very big problem for them. And the leaders should be very important over here of how do you solve the problems and everything. So I really like this quote because in my workspace and in some of the workspaces I worked in the past, the higher management is always reluctant to use more things. But I come across this quote quite a few times. It's basically that says that no matter what you do, you should always learn and unlearn, especially if you're working in an agile and a DevOps workspace, the illiterate so-called. And then, as I've told you that there is practices between the business and development and operations, and how exactly they fit over here is in the DevOps in the Scrum. So you must be all familiar with the Scrum lifecycle, taking down the feedback, taking down the backlog, break your backlog into sprint. Every sprint you have a sprint backlog and do things. You can work similarly with the operations, involve your operations inside the DevOps practices, inside the Scrum, know their feedback, say something that I want to deploy something into the environment, some application A. So is that possible? Is that not possible? Everything an operations guy will be knowing from the operations and the infrastructure level. So these kind of things will be put forward in the highlight right before when you begin the sprint. So you know that at the end of the sprint you don't have a blocker called I don't know what is happening, the ops guy is not responding to me. So if you involve him in this particular sprint, you'll come to know things much earlier than later. And then the DevOps and the Agile, as they say, both of them go hand in hand. The main priority is to satisfy the customer. So what way is to satisfy the customer is if your business gives you your customer gives you some requirements, you develop and you make sure that there is no downtime and all valuable software. It's the main priority. And then working software is again your measure of progress. And then the continuous attention to the technical excellence, and the good design will always make sure your system is robust. So what we have seen so far is again how can DevOps help? 3 ways by Ginny Kim. It's a super cool book called the DevOps Handbook. If you get a chance, you can just go over and read it. And DevOps and Scrum, and then top priorities. Finally, the most important thing which I wanted to talk about is the CALMS model. So CALMS model is basically it's a concept oriented framework which was built around the DevOps principles and the DevOps practices. How can things go in smoother way when you wanted to involve devs and the operations, because they have two different mindset, they have two different ideologies. Somebody wants to write more code, somebody wants to make sure that the deployments and the automations and the operations are smoother. You don't have any break in this network. So you must be hearing from your management saying, is the team DevOps ready? How can you make sure that whether it is DevOps ready, and what can be done whether it is DevOps ready to make sure your team is DevOps ready? So one such framework is called the CALMS model. So the CALMS means the C for culture, A for automation, L for lean, M for measurement, and S for sharing. All these 5 together leads you for the CALMS model. So again, as I say, there's a common misconception that Jenkins is DevOps. People come and say, yeah, I'm using Jenkins, I'm DevOps, but it's good you can keep it to yourself, but do not say to outside that DevOps, because it creates misconception among people and the message will be spread. So actually, this is one way you can measure your team whether they're improving or not by this framework. So first thing is culture. Pretty much simple. It's often called as collaboration. Some call culture, some call collaboration, but both have the same purpose. They should have a common desire between the parties that things should be working fine between things, especially the devs and the ops. So it's pretty much like agile way of doing, but you have an operations guy involved in this process. So when you involve the operations guy, that things will not be so easy. There will be a lot of hardships when they involve the operations over here, and then focus on the people more than the processes, and then trusting each other, self-organizing each other, and then engaging in the constructive conflicts will make sure that the collaborations and then the culture between them is more robust. So how can you do that? Open communication, collaborative workflows. The more you share information between the parties, the more communication is being shared and the more trust will be increased. These things might sound small, sharing information, how can it does? The more you share the information, the more trust will be created among the parties. And then respect, no matter what it is, automation or whatever, the testing, everybody should respect each other's job. That creates the culture. And then trust, as I said, operations must trust the development, and the development must trust the operations, and everybody should trust the QA. And then everybody should be again aligned, so nobody should have a different goal at the end of the day. Everybody should have a shared goal and work for a common result. And then what will happen at the end is, because when you have a common goal, you know what needs to be done, so all your defects or everything will be identified well in advance before you go to the production. So that is about the culture part. And let's see the automation part. So there's again a common quote that if you automate a mess, you get an automated mess every time you trigger that automation script. So always know what you want to automate. Do not just automate for the sake of automating, and you know your use case very well when you automate stuff. And then you must be hearing a lot that all the big folks are releasing items a lot. They push changes a lot, like Facebook, Uber, Netflix. A lot of them deploy every day to your application without you coming to know about it. But how are they doing it? How are they making sure that nothing happens? Is because they do release the code multiple times a day, as you have heard, but they do not enable the service for the people. They do it on a slowly basis, and then they have something called toggle features. So they toggle them, and some people will see the features and then they get the feedback and improve it, and then enable the toggle to every person who is using that application. And then when you do automation, often people get confused, like how do we manage our strategies, how do we follow our branching strategies. So there are two good ways of doing. There are many ways. One better ways are like the trunk based developments, where everything is done through the master branch, and then you check out code and you do your activities and push it back to the master. And so your basic flow is going through the master branches only. So when it is ideally suitable is because when you have a POCs where you cannot afford this so-called peer reviews and all, and when you want to do an MVPs or startup kind of projects. And also ideal situation is you have to have a senior or experienced people in the team to avoid issues, because if you have junior developers, there's a chance of smelly code going into the master branch, which will impact your stage later. So this is ideally meant for the senior and the experienced folks. And then the other one, which most commonly everybody use, the Git flow strategy. So as you know that you have this master branch, and then you have your develop branch, and you have your release branches, feature branches, and then you work on your features on a separate branches, and you push to your develop. You have a peer review, and then from the develop, the code will go to the release branches, and then you merge them on an effective level, and you push it back to onto the master branch, and then you tag it. So when is this possible? There's a pros and cons in both of them. This one is like you have a lot of merges. You need to verify the code, and if somebody doesn't push their code on a frequent basis, the code length will be pretty high, and then it will be difficult to validate. So ideally suitable when you have stable products, and then when you have peer reviews, when you wanted to do a lot of peer reviews before you push your code, and especially when you have a junior developers, perfect way to do, because you check your code, and you check the code and give feedback, and then you merge it accordingly. So this is the branching strategy. And then you have the infrastructure as a code and configuration management. So infrastructure as code is pretty much simple. What all you wanted to do manually, of creating an instance, for example, creating a virtual machine, you write everything in form of a template, and then you spin up this template and again multiple times to make sure that the things are not repeated, which you have done in dev. You have to do it in SIT, you have to do it in UAT, you have to do it again in production, and then some people call it pre-production. You have so many phases, so many times you need to redeploy the same thing. So IAC, which will help you in redoing the process in an effective way, and you don't need to go and request for VMs again and again. Basically infrastructure could be anything, could be a database, could be a load balancer rules, could be monitoring, everything. Basically the code should be idempotent. Idempotent meaning no matter how many times you run, the state of the machine doesn't change unless there's a new state implemented. So if you run the code second time, ideally nothing should change. So that is basically called idempotent. And then some of the famous IAC tools are Terraform, CloudFormation, and there's Azure templates, and then you have OpenStack heat templates. So everything is meant for creating stacks and creating the automation stacks. And you have the configuration management. Now that your infrastructure is up and running, you need some configurations also to be made on top of the infrastructure. So you have some tools like Ansible, Chef, and all other Puppet Labs where you can write your configuration, and then once you have a new infrastructure, the configuration management will help you facilitate in the tools and in the stack once you have deployed. And what happens is when you want to scale the infrastructure, when you want to do the modifications to the infrastructure, configuration management will help you to do that, because again it should be an idempotent, no matter again how many times, only the affected change should be replicated and the affected changes should be modified. So this is another code about the IAC. And then the most common thing, CI/CD. So you have Jenkins, you have Travis, you have VSTS and all. Basically you can deploy your source code from any source code management tool to any platform, and you can deploy to VMs, you can deploy to Lambda functions, you can deploy to S3, you can deploy anywhere. And to maintain static websites, you can deploy to S3s, and then you can orchestrate multiple environment pipelines also. So this is another way of making sure that you can deploy any source code wherever it is there. And then the test importance. So you often get this question that like, when I wanted to do a testing, where should I test? How should I test? What tools should I use for doing the test? And like, so the answer is pretty simple. You can test your code right from the planning state till the state again till it goes to operations, until it goes to monitoring. So there's no question that you have to source, you have to automate only, you have to test your only source code, you have to test only when it goes into the master branch, you do integration testing, you do UI testing. That's only not done for source code management only, because there's hell lot of to do in testing outside the source code. So how do you do that? So you have TTD and you have BDD, which is test driven development, and you have behavioral driven development, and you have security level testing and all. So for source code management, you can use some tools like SonarQube, which will tell you the quality of the source code, and then you have the Nexus IQ, and which is meant for vulnerabilities for the source code which you are using. And then you have the DAST and the SAST, which is dynamically you can do a software testing of the applications using the HP45. Is one of the very famous tool. It will tell you the security aspect of your source code, and it tells you how secure is your application. That is one way. And monitoring. So you have deployed your code, you have written your code, you have done your code, you pushed your code. Who will be responsible for how will you monitor your code? Because monitoring itself is a crucial aspect when you wanted to do. So as I said, that once the application go into the production, you should make sure that your applications is pretty good and fine, and you should not have any downtime. So how can you monitor these things? So some of the open source tools are like the TickStack, and then you have ELG, and then you have Prometheus and Grafana, which will collect your information, and then you can monitor, and where you can get your email alerts and everything through these applications. And you have some you have some enterprise offerings like Dynatrace, which will tell your application the health of it. So what we do is like a small thing. What we do in my workspace is basically we collect a lot of information. So we have to manage information, we have to monitor information in bytes, even in like no matter how small, even if it's in the bytes, we have to monitor. So we have written our own JMX exporters, which is on top of Java. So all the JMX exporters will be pushed and written to the Prometheus, and Prometheus will be capturing all the data, and Grafana is used to display the information. So any application, whether no matter what it is, the health of the application, the health of the node, everything can be, it works fine for Prometheus and Grafana, and it's open source. You can test it on your laptop also, you can monitor your laptop also. And then moving back, how are the big folks doing? So basically there are two kinds of deployments where pretty much everybody use. One is the blue-green deployment. You have a similar replica. Once everything is done, you change your load balancer, point you to the new environment. But I took this image from a website called VivaWorks. So basically they have this operator called GitOps operator. So I'm not going in detail of that. So previously what happens over here is 100% you will be monitoring, 100% you will be pushing the load to one particular environment. But once you change the environment, you get a lot of issues with scalability, with a lot of issues will come when something doesn't work over here and something works in the older environment. So this is actually, it is built on top of the Kubernetes, this particular thing. So you have this service mesh which will reroute, which will help to reroute the traffic, and then you can send your traffic to your old deployments. Like say for example 90% you're sending to the open old environment, and then you push your traffic to the new environment. Slowly by this, the traffic of older environment and newer environment, you get to know what are the failures, and then you can improve it, and then you can redeploy your stack based on this one. So this is called the canary deployment. So you split the load and slowly you migrate all your users to your newer environment. So this is you have a hell lot of tools for DevOps. Like you have for every purpose you have a lot of tools. Like for testing you see Selenium, Karma, JUnit, NUnit, QUnit, like the list goes on and on and on and on. So all these tools are meant for the DevOps collaboration for the entire stack. So you have orchestration, you have monitoring, you have the cloud IaaS, you have deployments, and you have artifact management. There's open source everything. You have enterprise versions also. Okay, next comes the lean part. So when somebody says about the lean, the most common thing which you hear is, main motto of the lean is to make sure that you don't have anything which is of waste. Basically you have to eliminate the waste and move your process faster. So by using your lean processes, first the team should sit down, identify what is necessary and what is not necessary, and cut it down and remove the practices, and then use the ones which are high priority. Eliminate the waste is the main thing, and based on that you can come to know when you learn from your failures, or like continuous improvements is being done. Again, how can we question about that? Over engineering, work in progress items, how much is the delays, wasted efforts, transaction cost. You have a lot of things which you can ask yourself whether this process is required or not required, because lean thinking in DevOps is all about increasing the customer value, eliminating the waste, continuous improvements, and then focusing on your long-term goals, and then having a short and a shared goals. And then the measurements. All you have seen about is culture, automation, lean, and everything. Now, how do you measure that your team is moving forward or is moving backwards or is it stable? No, I don't know how you do it. This is the question which you have. How do you question yourself is like basically, when you want to progress and you want to know how many things are you have a lot of ways to measure your team's improvements. So this I found this to be very relatability, because there's process measurements. You can measure your technology and you can measure your people, and this is how you can measure your thing. In going in detail, so when you say of technology measurements, what is the mean time to resolution, mean time between failures, how can you improve that, what is the mean time to customer impact. Previously the downtime when this particular service goes down is 20 minutes, how can I do it to 10 minutes? You can question yourself, you can have a metrics over this. There's no correct or bad, because every application is having their own limitations and they have their own values driven. And then process measurements. So it's about the release and change process. You have if you go to the big company, big MNCs, you have a lot of process involved. Take approval here, take approval there, take approval another place, and then finally some other guy will come and help you to do and facilitate the things. And then cost per release, time per cost is also another thing. There's another thing for measurements is the people measurements. Customer satisfaction, customer happiness index. There's another point which I didn't add it over here. It will be slightly debatable because it's about the employee retention. You can also measure how your team is doing well. If your team is doing bad, people actually tend to leave the company and look for another opportunity. So all these measurements are the ways to measure your team's progress, and you know how your team is moving on a daily scale. Yesterday it was something like this, tomorrow is this, and today is this. You can basically do your measurements and know where you are exactly lying today and where you are lying exactly yesterday. So basically based on that you can improve yourself on the processes. And then the last part is the sharing. So when you say about sharing, so sharing again, often they have, it kinds of overlap with the culture, but with some context in it. So no matter what, how big the information is, the information should be shared between the parties, especially the devs and the operations. Most people should understand that the things between both parties are not so smooth enough to discuss in easy. They will not, the devs will have a different mindset, the ops will be having a different mindset. So shipping your ideas, shipping your concepts and shipping your context between the parties is very, very important. And then sharing responsibility will make sure that your team will go a longer way, and basically breaking the barriers between the devs and the ops. And then you cannot expect every developer, of course, to know everything which the operations guy can do, but actually you can share the information. So it doesn't mean only sharing about your source code. It can be anything which you basically, the more you share about the application and the monitoring and everything, small minute details will create the trust. And once trust is built, the guy will be more helpful for you to work. And once everything is done, things will move smoother in the larger life cycle. So what we have seen so far is about the culture, collaboration, open communication and everything. And in the automation part is about the Git strategies, IAC, configuration management, monitoring, deployments, and the lean strategies, and then the measurements, and then the sharing. So what I really like about this particular model is most of the components get overlapped with each other. You do automation to reduce waste. So when you say reduce waste, it's again lean. So when you have this lean when you have the things automated, your process gets smoother and your time will reduce, and then you measure your things. So that's why all the 5 like models combined together is a framework which fits in over one another and then works indirectly together. So another example was like you automate something and you deploy something, you cut down the waste, and then you have the monitoring dashboards to know how things are going fine. And then basically what is exactly is DevOps is not a destination where you want to achieve. It's actually a journey for frequent and easy releases. And then the maturity model is based on how you assess your things and how you do your things. I don't know whether people know that there was AWS once had this very big DC outage issue, and then there was a lot of impact where many customers, big companies had this issue. They couldn't access the services and all. But there was this company called Netflix who overcame all these things, and they were the least impacted big customer in that particular time. The reason is because they have failed enough in the productions. They have something called a chaos monkey, which randomly goes down into your production server, cut down one virtual machine, take it outside the cluster and see the health of it. So these guys were prepared for all these impacts before. So if something happens like a data center outage or data center is out, like multiple data centers, these guys have shared their responsibilities and shared their services across, as they're ready for any impacts. So as I said, like you have to fail fast and fail more than to make sure that things are smoother and all. And that's it. Thank you. Any questions? You can. Oh.
Hello. I've got a question about just now you mentioned about Trump-based development.
Yeah.
Yeah. So I saw like the cons that you stated in your slide, which included like how the release might be unstable.
Yeah.
So there's this book by Jess Humble,
yeah.
which is about continuous delivery, which I read about, and it says that every commit is a release in Trump-based development.
Correct.
So supposedly, I don't think.
No, what I meant to say is that the cons was because there were multiple cons in that particular thing. When you have POCs and MVPs, every commit is something like you want to show it to the customers. So indirectly, what you're saying is my pros over there. Every commit is what you want to do, and in POCs and MVPs, you wanted to deliver faster things. And the thing which I wanted to say in cons is basically about the faulty code. So when you say everything is a commit into the production in the master branch, you should make sure that your code is perfectly fine. You cannot expect any smelly code in your master because it can break.
Yeah, got it.
That's what I was referring to.
Okay.
Okay. It's a QR code if you want to provide feedback. Yeah. And then, yeah, thank you.